Okay, kids. So we're going to do chapter 1 assignment number 14, and this is for 3U. So if you watch my other videos, you probably realize I always start with a G for given. Always. And I've been doing this a long time. I draw a picture. So I read the question here, and it says that a student throws a baseball vertically upward and 2.8 seconds later catches it at the same level. So I'm going to draw that. The ball goes up, and the ball comes back down. And it takes 2.8 seconds for this to happen. Now, we're neglecting air resistance. So a couple of things to keep take into account here. First, if you've ever thrown a ball upward at the very, 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 very top, I got to watch because I'm on the screen here. At the very, 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 very top, does anyone know how fast the ball is moving when it's right at the very, 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 very? So that means at the very top here, oop, come on. Where's my pen? The very top there, velocity at the top is 0 meters per second. The other thing I'm going to tell you about is motion has symmetry to it. Motion has symmetry to it. So time to go up is equal time to fall down. That means the time it took to go from the bottom to the top is equal to the time it took to go from the top to the bottom. Well, what must this time be if there's symmetry and the entire motion is 2.8 seconds? What must that time be? There's symmetry. They're symmetrical. If the entire time is 2.8 seconds and each half is symmetrical, that time up equals time down. What must it be? Nobody knows. Saloni? 1.4 seconds. Okay. And this, I haven't even started the question. This is the given. I hope you watched that video where I introduced grass to you. If you haven't watched the videos, then I don't know what to tell you. You're not learning. Okay. The other thing I'm going to remind you about is at the top, while it's moving down, and while it's moving up and while it's moving down, the acceleration is negative 9.8 meters per second squared. That's a property of the Earth's gravitational field. It's the same always during the entire motion. Okay? So when I do these questions, I definitely let up be represented by positive values. I always do that. And my acceleration is negative as it heads down. It speeds up as it's falling down. All right? So what they want to know is in the required, so here, now G for required, R for required, G for required, that's funny. R for required is how fast was it moving when you shot it upward? How fast was it moving when you shot it upward? So what we're looking for is velocity initial. How quickly did you throw it upward? Now, don't concern yourself with while it's in the person's hand. That's a totally different question. The question is, how fast was it moving just as it left the hand? That's my VI. That's what I want to calculate. And since I know that this is VI, by default, the velocity at the top becomes V what? F final. So really, to help you solve this problem, I split it into two, haven't I? Velocity upward motion upward with its velocity, and then motion downward with that velocity is involved. So here's the question you have to ask yourself. If you know the final velocity, so you know final velocity, and you know the time it took to move upward, 1.4 seconds, and you know the acceleration during the trip, is there an equation out there that will allow you to find initial velocity? If you know final velocity is 0, the time expired is 1.4 seconds, and the acceleration is negative 9.8 meters per second squared. Does such an equation exist? And of course, the answer is yes, and you can solve for it. Next, okay? So I'm not going to do that part for you, kids, because this is an assignment. You're going to have to do analysis, substitution, and solution. You got to do that. I got you started, okay? I got you started. You're going to have to do the rest yourself. Now, in part B of this, it's basically saying, how high up did it get? Well, kids, I don't have an equation that lets me calculate height, right? But I can interpret this height as its displacement. So my required becomes the displacement. Knowing, and remember, don't forget the things you know. I know it took 1.4 seconds to get to that height. Don't forget the things you know, like acceleration. As it was moving upward, it was slowing down because the acceleration is negative 9.8 meters per second squared. So is there an equation out there that will let you calculate, listen please, that will let you calculate displacement if you know acceleration is negative 9.8 meters per second squared, if you know the time it took to get to that spot is 1.4 seconds, and importantly, when it gets there, its velocity is 0. Can you find an equation that has acceleration, time, and final velocity that will let you calculate for displacement? Does such an equation exist? Oh, yes, it does. And that's where I'm not going to tell you. That's your job now. You got to do analysis. You got to do substitution. You got to do solution. Salone, is this helping? Okay. Oh, your name's going to be on a YouTube video. Is that okay? Okay. Okay, that's it, kids. Bye.